right now. Sorry, my pen is writing and I'm not touching the screen. So I'm going to try and keep the pen far away, then go in to write. It's going to be kind of weird. So what's the velocity of the ball after 3.6 seconds? So we said, what do they want us to find? V final. Well, they told us t equals 3.6 seconds. There's going to be that really thin, you can see those smeary lines. I apologize, but live with it. What else do we know? I underlined something in the original instructions, a word that began with the letter D. Dropped, which means what? It means VI equals 0. And if we're in free fall, I'll never tell you this, you need to know also, we know the acceleration. What's the acceleration? Negative 9.8. So I'm looking for an equation that has VF, T, VI, and A in it. Yeah, you're probably going to want access to your yellow formula sheet. VF equals VI plus AT. And technically, these are all vectors. Oh, that's terribly messy. What are we trying to find, Ange? Oh, it's by itself already. That's kind of convenient. So this is plug and chug. It's going to be 0 plus negative 9.8 times 5.6. 3.6, that's what I said. No, it won't let me. Oh, it will. Oh, wow. Okay, careful, Mr. Dueck. Let's let's erase this. Don't let me erase this. There we go. Let's go back to pen and not make any more mistakes. What do you say it was? 3.6? Yeah. By the way, is the ball moving down or up? So should I get a positive or a negative answer? I got some built-in error checks. So what is negative 9.8 times 3.6? Normally I would do this for you, but my pen and calculator are going to be an adventure, so you're just going to have to actually crunch the numbers. What do you get? Negative 35.28. Is that right, folks? Meters per second. I'd live with that. By the way, technically, though, how many sig figs should I go to? 3.6. How many sig figs? Okay, so technically I would say negative 35 meters per second. So we can certainly, if we drop something, figure out how fast it's traveling. What else? Turn the page. Oh, I can ask you how far it's fallen after 3.6 seconds. How far it's fallen after 3.6 seconds. It just magically fixed itself. Oh, that's Christmas. It's not doing the smear anymore. Oh, thank God. Did you guys all turn the page? Then I'm going to re-defic. If I was still on the same page, I wouldn't relist everything necessarily. I might just say D equals because I have everything right above. But since we turned the page, we said VI, oh, now it's back, equals 0. We said T equals 3.6. A equals negative 9.8. We did find VF, but I'm going to see if I can solve for D without using VF, because, Justin, I'm a good test writer. If I have to, I'll use what I found, but if I got it wrong, and I'm getting this one wrong. Hey, Justin, my friend, can you find an equation that has a D, a VI, a T, and an A in it? Oh, and I guess no VF. So you know where we're looking, right? Find the acceleration section, and it's those 4 that are sitting there in a row. I'm telling you, one of them works. One of them has a D, a VI, an A, and the T. Or more than one T, I think, in this case. Yes. Nice and loud. D equals? Justin, what are we trying to find? What's got the question mark? There's a reason we do use this method, right? What's got the question mark next to it? What are we trying to find? What's got the question mark next to it? What are we trying to find? Distant. Okay. Get the D. Oh, is the D by itself already in our equation? Well, this is convenient. Let's plug and chug. Oh, what's VI? You know what? That's just going to actually vanish because 0 times 3 points is still 0. It's going to be 0.5 times negative 9.8 times 3.6 squared, which is what? Which is what? What'd you get?
Negative 63.
Negative? What's the neg? Oh, are we below or above from where we started?
Below.
Okay, so that negative now, this negative means something. It is saying, by the way, you're below. Okay, sorry, what'd you say? Negative what?
Negative 63.50.
63.504. So really, I should, whoop. I got to erase with using the mouse, Mr. Dueck. Whoa, that was crazy because it's all connected, I guess. Okay, negative 63 point what?
504.
504, which would be to 2 sig figs, not meters per second, right? Just meters. E. By the way, I should tell you, I like A, I like A, I like A, I like B, I like B, I like B, I like C, I like C, I like C, I like D, I like D, I like D, I like E, I like E, I like E. You're going to get a question. Oh, yeah, you're going to get a question. I'm going to drop something, and I'll either tell you the time, I'll tell you some information and say find everything else, okay? E. How far does the ball fall during the 4th second of free fall? Put your pencils down for a second. Okay? So here's the ball falling. Yunk. Start your stopwatch. Click. Right there at time 0. The 1st second goes from time 0 to time 1. Does that make sense? The 2nd second, which I know sounds strange, goes from time 1 to time 2, and it would fall a bit further because it's traveling faster. The 3rd second would go from time 2 to time what? 3. Here's the key. The 4th second would go from time what to time what? Okay. When it says how far does the ball fall during the 4th second, I think what we're going to do is we're going to divide our page up into 3. We're going to find how far it falls for 3 seconds. We're going to find how far it's fallen after 4 seconds. And look up. We drop it. So in 3 seconds it falls this far. In 4 seconds it falls this far. How can I find this little distance, how far it fell in that 1 second? Let you think about it. Okay, so pick up your pencils, kind of divide your page into 3. How far, Colin, what does how far imply we want to find? Distance, yeah, okay. So I'm going to go D, you know what, I'll call this D3 for 3 seconds. I'll call this D4, hey, it stopped. Question mark? Question mark. What else do we know? Oh, VI is 0. VI is 0. And I guess for the 3 second, time is 3. And for the 4 second, time is 4. And it's free fall, so we also know the acceleration. What's the acceleration? Negative 9.8. Negative 9.8. Is that okay so far, Max? I'm looking for an equation that has time, velocity initial, A, and D in it. Anyone? Danielle? Oh, I thought you had it on your, I thought you were going to say it. You are right. D equals VIT plus a half AT squared. Danielle, I'm going to put a 3 to show you this is distance after 3 seconds, and D after 4 seconds is VIT plus 1/2 AT squared. Are any of these, Noah, 0?
Yep.
Which one?
0.
So that'll cancel and that'll cancel. That's convenient. So after 3 seconds, it's going to have fallen 0.5, a half, negative 9.8, 3 squared. How far does it fall after 3 seconds? Let's take a risk and see if I can get my calculator to work now. 0.5 times negative 9.8 times 3 squared. Do you get negative 44.1? After 4 seconds, it will have fallen 0.5, negative 9.8, 4 squared. You get negative 78.4. Meters and meters. Now, this is not what the question asked. Riley, what did the question ask? How far, what? So the 4th second is between, hopefully I've convinced you, between 3 and 4, because we start at 0. Okay. Don't write this down. Here's my argument, okay? So after 3 seconds, it fell 44.1 negative because it's going down. After 4 seconds, don't write this down, it fell negative 78.4. What I would like to find is, how can I find that? How can I find that? Cade, subtract them. Okay, and I think even with the negatives, it's going to work. So over here, you can pick your pencils up. What we're going to say is, how about we'll call it D fall, is going to be the distance it fell in 4 seconds minus the distance it fell in 3 seconds. That should tell us how far. It's going to be negative 78.4 minus negative 44.1. How far did it fall in that 4th second? Negative 78.4 minus negative 44.1. It fell 34.3 meters, and which way was it traveling? Down, negative 34.3 meters. So not only can I tell you how far it's gone from when we started, actually, Thomas, with a bit of cleverness, I can figure out how far it travels between any 2 times you give me. You want to figure out how far it fell between 5.5 and 5.7 seconds? I could do the same trick. Find the distance at 5.5. Find the distance at 5.7. Subtract them. And that's how far it fell in that little chunk of time. That's dropping something. Now let's throw something. How many of you have ever stood on the edge of a cliff and tossed something over? No one has? Safely, I should add, with nothing down below. So it usually works by like a beach cliff or something where there's like wilderness down below or something like that. Example 2. We're standing on a cliff right on the edge. Don't write this down, but here's kind of our picture. And we're going to throw something straight up. How fast? And then it's going to come falling down, thump. Okay? In fact, you know what? I've given you DFIC, data formula insert crunch. Here's another little acronym that I like to use. If I showed you DULP, DULP stands for draw a little picture. When in doubt, draw a little picture. And if you defic and you DULP, that's going to, believe it or not, bail you out about 95% of all of Physics 11 and Physics 12. If you have any friends that are in Physics 12, ask them about DULP and defic, and you'll see them, they'll all smiling. Oh yeah, first, when in doubt, I fall back on this. So let's draw, here's our cliff. We're going to throw it up. How fast? Read the question. 12.5. And then to show the future, I usually use a dotted line. It's going to splat down. What does this question want me to find? How high is the cliff? So you know what? I'll draw that like that. That's what it wants me to find. Okay, I already wrote VI, so I'm not going to re-defic it. What else has the question told me? What else has the question told me? It doesn't need to tell me because I know this. Jordan, what? Wait a minute, how can it be moving upwards at 12.5 and have a negative acceleration? Of course you can. You can be moving just like when you're moving forwards in a car and you hit the brakes. So if you're moving forwards, which way are you accelerating when you hit the brakes? If you're slowing down, backwards. The acceleration does not have to be in the same direction as the velocity. So we have that. What am I trying to find, Colin? Okay, so I'm looking for an equation that's got d, vi, a, and t in it. This is one kind of sounding familiar. Which is the one that has d, vi, a, and t in it?
E equals VI plus half AT.
VIT plus half AT squared. Conveniently, d is by itself already. Oh, I'll take that. So this is kind of plug and chug. It's going to be 12.5, 6.85 plus 0.5, negative 9.8, 6.85 squared. Cameron, are we ending up above or below from where we started? Look at my picture. Below. So before we even start crunching numbers, do you think we're going to get a negative or a positive distance if we're ending up, displacement actually, if we're ending up below? Yep. Let's confirm that, but I'm expecting it. I won't freak out. In fact, when I see a negative answer, I'll go, yeah, I probably did it right. Okay. The universe is on my side. Now, as I look around, I see some of you not trying to type these into your calculators. You're foolish. You're foolish. Please trust that I've taught physics for a while, and watching me type it is not the same as practicing yourself. And every year, I have kids that get to the test, and they haven't practiced typing them in, and they don't know how to get the answer to give them their answer. So get your calculators out. Yes, I'm staring at you, my friend. And, oh, you have it there. Sorry, it's a little thin one. I didn't see it. My bad. I'm getting, do you get negative 144.2? Did I type it right? 12.5, 6.85 plus a half, negative 9.8. Yeah, yep. Oh, and hopefully you're seeing, by the way, why it's so nice to have a multi-line display. You can see what you've typed and checked to make sure you haven't, made a typo. That rant I went on at the beginning was for good reason. Is it not negative 144.29? Yeah? How many sig figs should I go in my answer? 3. So I'm going to write negative 144 meters. Now, technically, Colin, you're right. It actually asks for how high. Height is technically a scalar, so if I was going to be really, really, really fussy, I would ditch the negative now, and I would, because we don't say, even if you're standing on top of a cliff, you don't say the cliff is negative 144 meters high. Just in English, we say, when we talk about heights, we always give a positive answer. But I don't mind the negative here. It's telling me, hey, I'm standing above looking down. Is that okay? Yeah, yeah? What else can we do? I can start to make predictions about how long and projectiles. I like example 3, I like example 3, I like example 3. Example 3 is a nice question. What was that? You can say it too.
You want me on the test?
I don't know, maybe you're a good student, tends to notice when a teacher tends to emphasize certain things. Good for you. Oscar, can you read to me part A?
How long does it take for the...
How long? What's it asking me to find?
Time.
Hey, let's write down questions no longer blank. I feel better. Okay. What have they given me? Velocity. Which one? Yeah. More specific. Can you tell me one and which one it is? Okay. Huh? I disagree. I don't think initial velocity is 0. I think it leaves my hand when I start my stopwatch at 32 meters per second. I think that's VI. Okay? And I'm going to convince you in a second. Jordan, have you ever just tried throwing something straight up to see how high it will go? A ball, a football? Yes? Okay. So I'd like you to imagine that. Definitely, it's not stopped when it leaves your hand. It's moving. It's got a positive velocity. At the top, how fast is it traveling for a split second at the top? Ah, Jordan, I'm going to argue with you. VI is not 0. You know what's 0? VF at the top. For a split second. An instantaneous velocity. Oh, we did instantaneous velocity a little. An instantaneous velocity. Oh, I know one more thing. Acceleration. We're in free fall. Okay. I'm looking for an equation that has T, VI, VF, A, and I guess it can't have a D in it. Oscar, you are correct. Let's write this one down. VF equals VI plus AT. Oscar, what are they asking me to find? See it? Do you see it? Yep. You see it? See where it is? Okay, what side is it on? I'm going to move everything else over. Are you ready? I'm going to pick on you. What's the A doing to the T? How will I move it over? Do that last. What's the VI doing to the T? How will I move it over? Do that first. So, you ready? What was on the left-hand side already? Drop that down like a domino. Can you talk me through the whole thing? What else am I going to write? What am I going to do next to get the T by itself? Right? Then, see the T? What else is there? So in your mind, you've moved that VI. Use your imagination at Sesame Street. You've moved the VI over. What else is next to the T? How would I move it over? See, this can be done. You will get good enough to do this all in your head, okay? So if I hear you correctly, you've just derived a new equation. Not on your formula sheet. Not going to put it on your formula sheet. Well, it is on your formula sheet, but I wrote it as VF equals VI plus AT. Oscar, what's VF?
0.
Yep. What's VI?
32.
This is why the DFIC approach is nice, because now it's really plug and chug, right? It's a little bit of setup, but it's worth it in terms of bang for your buck. Divided by negative 9.8. By the way, time, scalar or vector, who remembers? Time is a scalar, so I better get a positive answer. Now, on your calculator, is there more than one number in the top? Is there more than one number in the, you better put the top in brackets. You better go bracket 0, take away 32, divided by negative 9.8. I also heard somebody murmuring, you need to be aware, Amelia, there's a difference between a subtraction button on most calculators and a negative sign. Don't get them mixed up. Hey, by the way, among other things, by the end of this year, you'll be good with your calculators, which I think is a useful skill as well, especially in this technological age. You get 3.2653, that? How long does it take the ball to reach its maximum height? I'm going to write down 3.265, and then I'll do the sig figs. So 3.265, and then I'll put an equals. How many sig figs should I really go to here? 2, so I guess I would say 3.2 or 3.3? 3.3 seconds. That's yucky rounding off. Okay. Hey, Nick, what's B asking me to find? Ah! Did we defic everything on the question above? Then I'm not going to relist. I'll just go D equals question mark. If we had turned the page, just to be careful, I'd probably quickly relist it. So I'm looking for an equation. You know what? It has to have D. I found everything else, so really any equation that has D in it will work. Although I might avoid using time. Did I find time in part A? Let's find an equation that has a D in it, but no time. There's only one. Yep.
Vx squared is equal to vi squared.
Ready, Noah? This is going to cut your detention in half. Ready?
Yeah.
What are we trying to find? See it right here? See it right here? See it right here? Let's get it by itself. What am I going to do last with that 2 and that A? What are they doing to the D mathematically? Adding, subtracting, multiplying, or dividing? I'm going to divide by 2 eventually. How am I going to move this guy over? So if I hear you correctly, can you tell me what it's going to be? There's going to be a VF squared? Drop. Yes? Yes?
Divide by 2a.
What'd you roll?
5.
10 minutes right now. Follow that okay, Oscar? And I know it's a little weird at first, Justin, to do math with letters. I'm telling you, actually, it's easier in some ways. And if you wrap your brain around it, it's going to cut down on your memorization. Or you can memorize every one of these variations. If Cam, knock yourself out, go ahead. Don't do it. D is going to be 0 squared minus 32 squared all over 2 times negative 9.8. By the way, in this question, Nick, are we above or below from where we started? Read the question and think about it and use your imagination. Above, should I get a positive or a negative displacement?
Positive.
If I get a negative, I've goofed. Is there more than one number on the top? Brackets. Is there more than one number in the bottom? Brackets. I'm deliberately not going to type this. This is one you're going to be using an awful lot this year, so you want to figure out how to type it into your calculator. Yeah, I'm talking to you, Justin. Do you know how to type this in? Okay. Rest of you go. I get 0 squared minus 32 squared, close bracket, divided by bracket, 2 times negative 9.8. Now, you may notice, Riley, when I handwrite, showing multiplication with brackets is much clearer. But showing multiplication with brackets on a calculator, to me, is less clear. All these brackets I lose track of. You guys here? I see a bunch of you staring out the door. You here? I will, when I type, use a times. When I handwrite, I'll use the brackets for times. Y'all get 52.2? Okay. Technically, I guess to 2 sig figs. Oscar, did I tell you I like this question?
Yep.
Okay, suppose this was on the test, and I finish early. Can you tell me another way I could find distance? Don't write this down. You know what? I could have gone like this. The only reason I didn't, Danielle, I'm a good test writer, and I found T in part A, and if I got part A wrong, then I'm guaranteed to get part B wrong. But now I can use it as a check. I could go, hey, what was VI? 32. What'd we find for time? 3.265 plus a half times negative 9.8 times 3.265 squared. And if I get the same answer, then I know I'm right for both. Did I get the same answer? Yep. Pretty close. I've rounded off a bit, so by the 4th or 5th decimal, they're not going to quite match, but we're at the stage now already, and I've only given you really 4 equations, but we're already at the stage, Thomas, where you have more than one approach that you can use. And often, if I finish a test early, I'll go back and, heck, can I find it a different way? And if I get the same answer, then all of them must be right. It can't be a fluke. C. How long is the ball in the air for? Wait a minute, Mr. Dueck. I thought that was 3.3 seconds. No, that's how long it took to get to the top. How long is the ball in the air for? What's this question asking me to find? Time. There's a short way to find this, and there's a long way to find this. Just hang on a second. I may pause. How much more am I going to get through here? You know what? I'm going to go like this. Pause. You know what? Do this, Mr. Dueck. Pause here.